Hey guys, welcome back to another video on machine learning. So today we are going to talk about K nearest neighbors KNN algorithm with a live data set. So I'm gonna explain what is K nearest neighbors, what exactly, what is the purpose of using the K nearest neighbors where when it compared with the other machine learning algorithms. So far we have discussed about normal linear regression and also logistic regression, decision trees, and a random forest. So this is another machine learning model, so it can be used for classification as well as regression problems. So K nearest neighbors is a simple instance based machine learning algorithm that can be used for both classification as well as regression tasks. So KNN is a non-parametric lazy learning algorithm. It doesn't assume any underlying data distribution, non-parametric, and doesn't require training in the traditional sense, which is nothing but a laziness. Instead, it makes decisions based on the entire training data set each time a prediction is required. So the basic, so the below image, which has a clear-cut example of how this K nearest neighbor works. So here you can see we have this image of all the a circle and squares and triangles, and we just wanted to classify what kind of image this is. We don't know, which is not a labeled data, which we have unlabeled data and the surrounded by different data points. And when we train the model with K nearest neighbors, and machine will predict this data point based on the nearest points. So that is how the learning, this machine, this model will works. So here you can see, here it is a circle, and we are just feeding the model. After training the model, we are feeding these data points, and we are just asking the middle machine to predict. So obviously the nearest point is a triangle, and a second nearest point is also a triangle, and another nearest point is a square. So we need to specify the k. K is nothing but the number of nearest points, so that the machine will, as per our requirement, if I give k is equal to 2, k is equal to 3, k is equal to 4, k is nothing but the how many number of points should the machine consider as per the required data point. So my data point here is this, and I'm giving a number of, k is equal to number 10, which nothing but the machine will check all the nearest 10 data points which is associated to my data point. And based on that, machine will classify the given data point as per the nearest data points. So this is how, this is a basic information about k nearest neighbors. And so as I said, it can be useful for classification. So given the new data point to classify, the algorithm finds the k nearest point from the training data set. So based on the distance metric, commonly, so we do have different distance matrices. So commonly we'll use Euclidean distance matrix. Is it assigns the class of the majority of these k nearest neighbors to the new data point. So that is whatever we explained above. So with the given new data point, so let's assume this is a new data point and I don't know which class this data points falls under. And once the machine has been trained, so machine has been trained with this already existing data points, and machine already categorized or classified like a point with this category characteristics has to be classified into a square, and has to be, this has to be into a triangle. So when I feed the new data point, so it will check the all the nearest neighbor points, then it will, the new data point will be classified based on the nearest points or based on the conditions we are giving. So that is how this algorithm works. And when it comes to regression tasks, so KNN predicts the output by averaging the values of the k nearest neighbors. So this is for regression tasks. The KNN predicts the output by averaging the values of the k nearest neighbors. So that is for regression, and this is for classification. And so as we mentioned, this distance matrix, right? So let's talk about this distance matrix. the choice of distance matrix can affect the algorithm's performance. So common metrics include Euclidean distance or Manhattan distance and Minkowski distance. So we do have several distance matrices, so we can take as per our requirement. So, but the choice of distance matrix can affect the algorithm's performance. And so, as I said, k is nothing but the number of neighbors. The number of neighbors k is a crucial hyperparameter. A small k makes the model sensitive to noise, while a large k makes the model too smooth and less sensitive to the local structures. So that is how, if I wanted to take like uh, k is equal to 3, a smaller number, the small k makes the model sensitive to the noise. And if I take k is equal to a very high number like 100 or 150, something like that, then the model is too smooth and less sensitive to the local structure. And the I mean, the advantages of this using this k nearest neighbor is like it's simplicity, easy to understand, and we can able to implement it easily. And no training period. KNN doesn't involve a training process, making it useful for real-time applications. So that is the advantage, and also the versatility can be used for both classification as well as regression problems. So that is a versatile nature of this KNN algorithm. And the computational cost, the algorithm can be slow for larger data sets because it needs to compute the distance to all the training points for each prediction. So for example, let's assume the above data set. So here if I have a very small data point, so that the machine will able to look at the all the nearest points. If we have very if we are working on a smaller data sets, obviously we will be having smaller data points. Then it is easy for machine to understand, okay, what are all the characteristics of each and every data point. But whereas if I have data points in a millions, then it is very hard, and also it will take a lot of time if I use this KNN algorithm on larger data sets. So that is one disadvantage about KNN. and and also the memory intensive. So it requires storing the entire training data set because it has to compare with each and every other data sets. So that is what. And sensitive to irrelevant features, which is very sensitive to the irrelevant features. Performance can degrade if the data set contains irrelevant or redundant features. So it is very sensitive to the irrelevant features. If you have any irrelevant features in my data set, it is very sensitive to that irrelevant features. And applications, the applications of this k nearest neighbors is like pattern recognition, like handwritten recognition. If I have any images with handwritten notes or handwritten drawings or handwritten digits, so we can use this k nearest neighbors. And also for image classification, so if I wanted to classify different cat, dog, or any fruit images as per their category, so we can use this k nearest neighbor. And also we do have a lot of applications under medical diagnosis, so we can able to use this k nearest neighbor in classifying disease based on patient data and recommendation systems. So I think this is the most useful applications, because whereas the recommendation, like, so if I'm looking for a movie, or if I'm looking for a sports video, or if I'm looking at a comedy video in YouTube or any kind of a streaming platform like Netflix or anywhere, so obviously I have get a similar kind of videos. For example, if I am looking at any sports video, so all the or other related sports videos also I can able to get. So that is how the recommendation system works. So that is where we can also use this k means, I mean KNN machine model for recommendation, recommending products based on the user preferences. So here is another example of how the KNN works. So for example, this is my new data point, and if I give k is equal to 3, so obviously it will check nearest 3 points. So it will check this point and this point and this point. So if I give k is equal to 7, So this is my point. This is my new data point, new example to classify. So here I wanted to classify this new data point based on the nearest 3 points. If I give k is equal to 3, or if I give k is equal to 7, it will I mean it will check all the nearest 7 points. So 1, 2, 3, 4, and 1, 2, 3, 7 points. So that is how. And based on this 7 nearest points, and the machine will classify the new data point. If I give k is equal to 7, if I give k is equal to 3, based on the nearest 3 points, the new data point will be classified. So this is another example how the KNN works. So let's jump into a data set, so where we can able to work or how this model will works. I mean, let's jump into the coding part. So this is about the theory part, how or what is k nearest neighbor. So let me import all the necessary libraries. So pandas I used for data manipulation, numpy for mathematical computations, cborn for advanced visualizations, and I'm using matplotlib to just to visualize. If I wanted to visualize predictor versus already actual value, something like that, I can use this matplotlib library. And I imported warnings. I don't want to see any warnings. So this is my data set. Here I'm using wine quality data set. So where uh, I'm applying this KNN, so that the quality of the wine will be like classified into different classes. For example, if I have 1 grade, 2 grade, third grade, fourth grade, fifth grade, something like that, so the machine will segregate the quality of the wine. If it is A grade wine, then it will be put into the A grade wine, B grade, C grade, as per the input features we have. So that is how the model will work. So this is my data set. So if I look at the data set, this is my data set. It has fixed acidity, volatile acidity, citric acid, residual sugar, and something. So these are all the features, and this is my our target variable, which is classified, or which is with the numbers. Like it has classified into some like 1, 2, 3, 4, 5, 6, something like that, based on the quality of the wine. So if I feed, after training the model, if I feed the new data points with above features, machine has to predict as per the input features, then what is the quality of the wine. So first we need to train the model. And so this is about importing the data set, and also we looked at the head of the data set. And this is about this is comes under the data pre-processing. So if I wanted to look at any null values in the data set, so that it will affect the performance of the machine model. So that is why before training the model, I need to check any missing data or any null values in the data set. So this is how I checked. And if I have any null values, so I have to drop it. So I dropped. And also now I'm training the model. Like now I'm splitting the data into training and testing data set. Because once if I segregate my entire data set as 100%, and 60% of the data I'm using for training purpose, and once that machine has been trained, I will use the testing data to predict the results. So that is why I divided my entire data set into training and testing. So my X train, X test, Y train, Y test. So train test split. Test size I'm giving 30%, and 70% I'm 70 percentage of the data I'm using for training purpose. Random state I'm giving 42. So this is how you can split the data for training and testing purpose. And once we are done with the training and testing, now the model. So I imported the model k nearest neighbor classifier because I'm working on a classification problem. So here my target variable is the quality based on the features. What is the quality of the wine? So let's take, I'm grading the wine with 1 to some numbers, and based on the characteristics, so if it is falls under first grade, then number one, second grade, number two, fifth grade, it is represented as 5, something like that. So that is why I imported k nearest classifier. So I trained the model. So model.fit will train the model. So this is my model. Model has been trained. Now I need to make some predictions. So if I wanted to predict model.predict, I need to pass this testing data set. So I feed it the testing data set. So then if I wanted to evaluate the model, so here you can see I just imported accuracy score and classification report so that I can able to evaluate the model performance. So since it is a classification problem, I need to look at the accuracy of the model, how accurately the machine is performing, and also the classification report will give me the precision, recall, F1 score, and support. So here you can see accuracy we are getting around 56% and 56% and uh, so for the classification 3, the precision is 0% for 4 0 and 5 it is giving is 62%, and for 6 it is giving 54%, and for 7 it is giving you 47%, and recall also you can see recall, you can see F1 score, and you can see support, something like that. So now my model has been trained. So this is my basic data set for wine quality. Now I just cleared if I have any null values. I'm done with the data pre-processing, and I split the data into training and testing data set, and I trained the model. And if I pass my testing data set, so my machine is prediction. So I got the predictions also. Then if I look at the, or if I wanted to look at the performance of the model, so I imported accuracy score and classification report. So this will give me the accuracy and the classification, like precision, F1 score, support. So now I wanted to test the model with a new data set. So this is my new data set where my machine is predicting the input features are for the class 5. So I just imported np.array xtest.ilog, like from the from the same data set only. I have taken one replace with your sample data. So that is what. So if I feed this input features, I am getting that. Okay, so this features has this quality of wine of 5 class. So if I wanted to plot predicted and actual values, so I imported matplotlib, and I'm just giving this basic steps, like I wanted 10 centimeters x-axis, 6 centimeters y-axis, and I just wanted the scatter with some range and also colors. I wanted to show actual values in blue color and predicted values in red color, and I'm giving X label as sample index and Y label as class, and title I'm giving predicted versus actual values. So this is how you can see the machine has been predicted the value. So here you can see the blue dots are actual values and red is for the predicted value. So if I look at the third class, fourth class wine, fifth class, sixth class, seventh class, and eighth grade, I can say grades also. So here you can see in fourth grade, so almost exactly the machine predicted how the actual values are. This is my actual value, and my machine is also predicted very similar to that. Whereas in case of fifth grade, almost similar. Oh, the points are overlapped. So my actual and predicted values are same. Whereas it comes to the sixth grade wine also, seventh grade and eighth grade wine also. So this is how we can take one sample data set and we can apply the k nearest neighbors, and the machine will look at the nearest points, how the quality of the wine. And I mean, if I feed the new data point, it will look at the, I mean, nearest points. Then as per the nearest points, if I give k is equal to 3 or k is equal to 7, something like that, it will check the number of nearest points as per my requirement, and then it will predict the result, or it will classify that new data point into the existing classifications. So that is how we can work on this k nearest neighbors, and I hope it is clear and simple. So if you have any further questions on this, you can feel free to comment on the video, and if you really like it or if you are able to understand the concept easily with this explanation, so please do like the video. So if you have not subscribed, please do subscribe the channel so that it will encourage me to do further similar kind of videos. So thanks guys. See you in other video. Bye.